Hello friends, myself Anmol Jain, Assistant Professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Today I am going to discuss that how we can design an 8-bit ALU, right? So what is the object of the ALU? That is that can perform the arithmetic operation and logical operations. So I want to design a unit which can perform the arithmetic and logical. In arithmetic, suppose addition, subtraction, multiplication and division operations should be performed, and in logical, suppose AND, OR, NAND, NOR, etc. Such type of logical operations can be performed, and the output and input size should be the 8-bit ALU. That means the input size should be the 8-bit. So let's see that how we can design using the logisim. So we take a new project here. So for making an arithmetic unit, we go to the arithmetic unit or the arithmetic family, and we select an adder, we select an subtractor because we want to perform these operations. We take a multiplier, we take a divisor, that is the divider. Next we take the suppose logical units, suppose NAND gate, AND gate, then suppose the OR gate, NAND gate, and the NOR gate, right? So and the 8-bit ALU, so we have to take two 8-bit input. So this is my first input, this is my second input, and make them out of 8-bit each. I'll make them of 8-bit each. So take care of the directions also. It should be south, it should be south. So these inputs should be transferred to each component. This is the input 1. So input 1 is transferred to each component. Right. So here we should take the two inputs. This is of two inputs. That is of two inputs. That means each gate should be of two inputs because we are dealing with only two inputs. So the first input, so data bits must be of 8 inputs, right? So here the data bit must be of 8 bit. This must be of 8 bits, and the last it also must be of 8 bits, right? Now we have 8 operations which we can perform on two numbers of 8 bit. Attach the second input to the next input of each component. right? Next time. So now my objective is that out of these 8 inputs, any one component should be selected. So the selection of input can be done using the multiplexers family. So I take a multiplexer. Now the question is that what should be the size of the multiplexer? So we are having 8 inputs. So the size of the multiplexer should be 8 cross 1. And for designing an 8 cross 1 multiplexer, we should have 3 selection keys. So we take an input of 3 bits. It must be 3 bits, right? So when all the zeros, then it should work as a adder, right? Data size should be also of 8 bits. When 001, then it should work like a subtractor. When next input is given, then it should work like a multiplier, and so on. Right? So output should be here now. So we take an output. Output is all again 8 bits. Right here. So I have now 8 component, that is a adder, subtractor, multiplier, divisor, and or NAND NOR gate. And when this is 000, then it should work like a adder. When this is 001, it should work like a subtractor. So I can change the values here also, and you can see the output also, right? So when we perform the adder or subtractor, then we should also consider its the carry bits. The carry will be of suppose 8 bits, so we should also consider that. Carry and borrow. Similarly, as we multiply the two numbers, the output is of doubles, that is a j plus k bits. So we should also consider the multiplication. So it should be of 8 bits now. Similarly for the division operation. So now this is complete arithmetic and logic unit. We are having 2 inputs here and here, and the single output, and the output depends on the values of the selection keys, that which component you are using. So suppose I use the 111, so it should be an output of this, that is the not of OR gate upon these two inputs, right? So you will see that this is the output of this operation. So in this way we can design an 8-bit ALU. Similarly, we can change the size of this 8-bit ALU just by changing the number of inputs here. That if it is 8, then it will be called as a 8-bit. If it is 16, then it will be called a 16-bit ALU. If it is 32, then it will be called as 32-bit ALU, right? So we can design the ALU. Thank you.